Hello class, this is a video tutorial on permutations part 2. In this video, we'll be looking at the condition of identical objects. So here we go. So certain scenarios require more consideration when counting arrangements. Such examples would be identical objects, circular seating arrangements, selective criteria, and a mixture of the three listed above. In this video, let's look at identical objects. So I'm going to give you 4 letters, D, G, O, O. How many different ways can you arrange this? I want you to pause and actually give it a go. I'll start you off here. You could go D, G, O, O. That's one way of doing it. You could go G, O, O, D. That's another way of doing it. You could go G, O, D, O, and so on. Want to see if you can figure out a systemic way of counting every single one of them. So pause and give it a go. I really hope you've given it a go because we're going to continue right about now. So notice how if we try and systemically do this, I did it by alphabetical order, you'll see that there are a few that are identical. What I've done actually is I've color coded it and given the 2 O's a number to differentiate between the two. So DG0102 and DG0201. Here's another one, D01G02, D0102G, D02G01, D02O1G. Notice how when you label or color code them, they look unique. But in reality, because they're letters, there is no color coding and there is no numbering like this. So if we tried to do this systemically, you'd find that there are actually a few that are identical to one another. So we couldn't just count them in this manner. And even if we wanted to, it would take a very long time because this is at least 4 factorial different ways of doing it. Okay? Not to mention, how do we figure out which ones are identical and which ones aren't? Now, to account for these repetitions, we divide by how many ways just the repeated objects can be arranged. Now that seems to be a little bit more wordy than it is, and I'll try and be a little bit more precise in my definition here. So permutations with repeated objects from a total of n objects where there are x identical objects, y identical objects of another type, and z identical objects of another type, and so on. So you can have as many identical objects as you want. The total number of arrangements are, as per usual, n factorial. But now we're going to divide by x factorial, where x is the number of one type of identical objects. Y factorial is another type of identical objects, and so on. So, for example, as we saw in this example, DGOO, I took it from the word good. How many ways can these letters be arranged? Well, going by this, n factorial is the total. That's 4 factorial. So the total ways or arrangements is 4 factorial divided by, well, O are identical and there are 2 of them. So divided by 2 factorial, whatever that is in the calculator. I believe it's 4 times 3, which is 12 different ways. It's as simple as that. So here's another example. How many ways can the letters Woolworths, WOOLWORTHS, be arranged? Well, first we need the total number of letters. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's going to be 10 factorial. Now we divide by how many of them are identical. Let's take a look at the first type. W, that's 1 and 2. So we divide by 2 factorial. Then we look at the other types of identical objects. Let's color code this. Let's use the black marker. O, that's 1, 2, and 3. So we divide by 3 factorial. And I think that's it. Do you see any more identical objects? Well, that's about it. Whatever this is in your calculator. Let's see. Oh, no, this can't do it. I'm just gonna grab my physical calculator. I can't do this on my iPad calculator. So 10 factorial divided by 2 factorial, whoops, times 3 factorial. I'm writing it exactly as shown here. Oh, sorry, but that doesn't work. I guess you need a multiplication in between. Let's see. Yep. There we go. This gives me 302,400 ways. And that's pretty much it for identical objects. So it's as simple as the total number of ways divided by the repetitions of each type of identical object. So, hope to see you in the next video. Best of luck.